Hi guys, let us discuss another concept, electric flux. What is electric flux? Electric flux is defined as the amount of electric field passing through a surfaced area. So this enables us to calculate the electric field through different surfaces. First of all, to calculate electric field due to different surfaces, maybe a spherical ball or a hollow ball or a cylinder or a infinite line, infinite wire, like that, different surfaces. For that, we need to calculate first electric flux. What is electric flux? Electric flux is the amount of electric field passing through a surfaced area. I will explain that in detail. First of all, what is flux? Flux means a flow. A flow, a Latin word. So that known as flux. See the diagram at here. So this is a water tank filled with water. Water is flowing through a pipe. So in this place, if I take a surface of area, so this is the rectangular surface having area. Now I would like to calculate through that surface how much water is flowing. Repeating again, I need to calculate through that surface how much water is flowing. So if we can able to calculate that, so that I known as water flow or water flux. Now if you change the position of the area in this pipe only, earlier itself just like perpendicular, now this surface area is making an angle. Now if you make an angle at here, automatically the water flow, the amount of the water flowing through it also changes. We need to apply same analogy to our electric fields. Let us apply the same analogy to our electric field at here. So here I am having two figures, electric field lines due to negative charge. One is having, if we take this is minus q, if this charge is equal to minus q, here electric field lines are more, I could take that charge minus 2q, because if the strength of the charge increases, electric field lines also increases. Now I have electric field lines. Where is my surface? So that is you yourself free to choose your surface. Now let me take a rectangular surface at here. So I am drawing a rectangular surface. Now keep in mind, this surface is having area. This surface is having area. So we need to represent that area vector. So I can call that A bar as area vector. Where is the area vector? Area vector will be just perpendicular to the surface. Suppose if I draw, this is a surface, to the surface perpendicularly, area vector we need to draw. Okay. Now through the surface, how many electric field lines are coming out or coming in or going through? through the surface, how many electric field lines are going through? The answer is 1. Number of field lines going through surface equal to 1. That's correct. Here only one line is going through it. Suppose if I take the same surface, but I bring that same surface to at here. Now surface area is same, area do not changes, but if you bring that to another charge setup which is having more electric field lines, now number of field lines going through surface equal to, in this case how many field lines are going? 1 and 2. In this case number of field lines are going 2. Now how can I define the electric flux? Electric flux means nothing but this is a number. Flux is a number. The number of field lines passing through a given area is defined as electric flux. The number, it's a scalar number, a quantity. The number of field lines passing through in a given area is defined as electric flux. That is the flux definition. Repeating again, the number of electric field lines passing through or coming out through given surface area or unit area is defined as electric flux. So mathematically we can write flux pi equal to E bar dot A bar. Here I can write clearly flux pi equal to E bar dot A bar. E bar means electric field, it's a vector, and A bar area, it's a vector. The dot product of two vectors, or precisely we can write flux pi is equal to E times A cos theta. So here theta is the angle between electric field vector and A vector. So this is the mathematical formula for flux. So a simplest concept, electric flux, according to definition, the number of electric field lines passing through a given area is defined as electric flux. Flux is a scalar quantity because it's a number, how many number it is flowing. Let us see the example at here, the perfect explanation for the flux. So here my pink lines are electric field lines. Now this is the area which I have taken. So this is my surface area, and this is my area vector A bar. Now the electric field lines and the area vectors are parallel. The angle between them goes to 0. According to this, surface phase on electric field E bar and A bar parallel, angle between E bar and A bar equal to 0. Therefore flux phi equal to E bar dot A bar equal to EA. So what the formula you can take? Flux pi suffix E means electric flux equal to E times A cos theta. Here the angle have taken as a phi. You can take any angle, there is no problem to represent. Therefore, flux E equal to, in this case, theta equal to 0. So therefore, EA cos 0. So flux pi E equal to E times A. In this case, if the surface is parallel to electric field lines. If the surface is parallel to electric field lines. Coming to this case for the better understanding. Here you can see the electric field lines are pink lines, they are going. But here the surface is exactly 90 degrees to the earlier case. If you can turn earlier surface to anti-clockwise 90 degrees, now the surface is in this direction, the electric field lines are moving in this direction. Now here A bar is the area vector of the surface and these pink lines are the electric field lines. What is the angle between them? The angle between them at here, area vector and the electric field vector, the angle between them here goes to 90 degrees. Now in this case, what is the flux? You can apply the same formula, electric flux pi E equal to E times A cos theta. So phi E equal to EA cos, here the angle goes to 90 degrees, cos 90 value 0. So electric flux goes to 0. In this case, the flux equal to 0. But, so these are the two opposite cases. The flux depends upon the area orientation, electric field direction and the area direction. Now you take another case which is in between that. Suppose you made an angle, area made an angle with the electric field lines. So this is the area, it is make an angle phi with the electric field lines. So these are the electric field lines and this is the area. Now in this case, what is the flux? Flux pi E equal to E dot A dot product of area vector and electric field vector. So this you can write in terms of E times A cos angle between them. Here the angle between them goes to, I am taking as phi. Phi is the angle between them. Angle phi equal to angle between E bar and A bar. E bar is electric field vector and A bar is area vector. Area is a vector. Now in this case, the flux E equal to phi E equal to, we can write, we don't know what is the exact angle, so we can write simply EA cos pi. If you know the phi value, we can substitute there. So that is the way to calculate the flux. Flux depends upon the electric field and the area and the angle between the electric field vector and area vector. Now let's see some more factors which are affecting the flux, electric flux. The first one is electric flux is directly proportional to electric field strength. Here you can see this is the circular area which I have taken. In this case, through the circular area, how many electric field lines are the flowing? So electric field lines are the flowing 1, 2, 3. 3 electric field lines are the flowing through the surface area. But if we can increase the electric field strength, If I increase the electric field strength, now in this case the electric field lines in this case are increased. 1, 2, 3, 4, 5, 6. Now the electric field strength increases, automatically flux is also increases. So in this case the electric field strength, only the 3 lines are passing through the circular surface area, but in another case the 6 lines, electric field lines, are passing through the circular surface area. In this case the flux is directly proportional to the electric field strength, or in another words we can say density of the electric field. Second point, flux varies by how the boundary faces the direction of flow. Suppose if you place the surface area with this angle, now through this surface area how many electric field lines are the flowing? They are the flowing only 4. Because of the orientation of the surface, the number of field lines passing through the surface also changes. In the same case, you can see in this case the orientation of the area, surface area, in this case is entirely different than that. Now in this case how many flux lines are the flowing? So the number of flux lines are the flowing in this case are 6. It means if you change the orientation of the surface area, the flux also gets changes. Now last point, the flux is directly proportional to area within the boundary. It's a common sense. If you take small area, here you can see the area of the circular loop in this case is smaller comparatively at here. Here the surface area more. If the surface area is less, so through the surface area the number of lines are the flowing also less. If you increase the surface area, the number of lines of force also increases. So we can write flux, electric flux is directly proportional to strength of the electric field, strength of E field, and electric flux is directly proportional to area, surface area, and electric flux is directly proportional to theta, angle between E and A, electric field and area vector. So together we can write flux pi E equal to E A cos theta. So this is the electric flux concept. And so when the flux will be maximum, it depends upon the electric field strength, and it depends upon the area, and it depends upon the orientation of the surface area with the electric field.